Hi guys, welcome to Snowflake training demo class. In this class, we are going to see different kinds of modern database architectures and two kinds of data warehousing databases, on-premise, and the other one is cloud-based data warehouses. And we'll see the comparison between these two in terms of database activities and data engineering or data warehousing practices. With the knowledge we acquired from the two topics that I have mentioned, we will start understanding high-level architecture of Snowflake. If we understand the architecture of Snowflake at the high level, it helps us to focus on the topics which we are covering as part of our training program. Okay, let's start the demo class.
There are three types of databases. They are OLTP, OLAP, and NoSQL databases. Let's talk about these databases. First, OLTP. OLTP stands for Online Transactional Processing Machines. They are used to collect the transactions data. These OLTP machines runs very few known lightweight queries only. They are intended to gather the transactional data, not to run heavy queries for business reporting or for any other reasons. To explain the OLTP machines, we can take an example of the machines which you see at the billing counters in supermarkets. Those machines gathers the data about the customer and the items that he has purchased and the quantity of those items and the mode of payment and the total amount to be paid. So all these details will be collected and sent to the OLTP machine. These OLTP machines follows
shared disk architecture. Let us discuss about shared disk architecture. In shared disk architecture, we have a processor. Under that, we have the disk. Whenever you are inserting the records in OLTP systems, those records will be stored in the subsequent data blocks of the disk. So we know what is data block, right? Data block can hold one or more complete records. It cannot hold 1.5, 2.5 like that. Think that I have an employee table and now I am inserting 100 records into that table. Now what happens? All the 100 records get stored in these subsequent data blocks. Think that one record got stored in each data block. Now whenever I say select star from employee table, control goes to these data blocks and starts reading all these data blocks in sequence. In our case, we have 100 records. To perform that operation, it needs 100 cycles. Okay, in OLTP architecture we don't see much parallelism because data gets stored under the same disk. Suppose think that this processor has X number of threads. Think we have 8 threads. 8 threads will work for 8 different transactions, 8 different statements. And in case of OLAP systems, so basically OLAP stands for Online Analytical Processing Machines. Alternatively, we can call data warehousing databases, or people call it as MPP systems, massive parallel processing systems. OLAP systems are used to collect the data from OLTP systems and keep the data ready for business reporting, or you can say to generate the reports so that people can take the flexible decisions over the business. Generally, OLTP machines always works with the current transaction data. But whereas OLAP machines works with historical data. Since it has a lot of history, when we compare to OLTP machines, we have huge amount of data in OLAP machines. Since we have huge amount of data, we should have more computing power. That's why in OLAP systems, we have n number of processors and there are n number of disks. So let's take the same example where I have an employee table. Now I am going to insert 100 records. Let's see how the 100 records gets inserted and retrieved from the database. Whenever you are inserting the records in shared nothing databases, records will be distributed among these disks. So think that now I am inserting 100 records in an employee table. So those records will be distributed and think that each disk has got one record under it. Whenever you say select star from that employee table, that statement will be broadcasted to all the processors and each processor takes the responsibility to fetch the record which is inside its disk. So all the processors work in parallel and brings 100 records in a single cycle. When it comes to the Snowflake, it is an OLAP database. Now let's look at the NoSQL databases. The main intention of NoSQL databases is storing the unstructured or semi-structured data which is coming at its speed from thousands, even from millions of devices. For example, data that is belongs to web logs or click streams, social media, web analytics applications, for example, Google Analytics. Generally, these NoSQL databases stores the data in the form of JSON format. These databases gives the facility to retrieve the data whenever we need. These NoSQL databases can be one of the sources for OLAP databases. So OLAP databases not only collects the data from OLTP, they can also get the data from NoSQL databases whenever needed. MongoDB, Cassandra, DynamoDB, these are the famous NoSQL databases. Among these three, OLTP, OLAP and NoSQL databases, there is no winner and there is no loser because these databases are used to support in different scenarios. There are different kinds of NoSQL databases. Like we have document databases, key value stores, wide column databases, and graph databases. These databases are used to store and process different kinds of data. We need to choose a NoSQL database based on the type of data we have in hand. Basically, in OLAP databases, we have two different types. One is on-premise data warehouse. The second one is cloud data warehouse. So far, we were using on-premise data warehouse. Let's see what are the advantages and problems we face when we were on on-premise data warehouse. Basically, on-premise data warehouses suffer with resource limitations. We have to plan before to bring the data into the data warehouse because here resource is limited. So previously, people used to plan how much CPU and how much disk is required. They used to upgrade their systems to hold the new data. But nowadays, what's happening? The data demand is more. So we don't know with what data we have to play with. And planned workloads kills overall system performance. Suppose if I am running a query which runs longer, which pulls a good amount of data and performs some heavy calculations, and I need the result of this query for marketing team. If this query is running on the system, the jobs which is supposed to run daily, they will get impacted. And to run this particular query, I need to find the slot which is the best time to run this query. So this way, we used to face the delays because it is an unplanned workload. And if you are an on-premise data warehouse, we have more maintenance tasks. Example, so we need to apply security compliances, system upgrades, archives, data compressions, log cleaning, and running the disk management jobs, etc. And one more point is there will be expected downtimes. Suppose if I want to add more CPU or if I want to add a new disk subsystem, then I can add that new configuration while this on-premise data warehouse is running. I can add, but to bring those newly added components in action, one system restart is required. It may take 1 hour to, it may take couple of hours based on how much data we have and the additional disk that we have added. And on other hand, we have cloud-based data warehouse. So let's see what are the features these cloud-based data warehouses have and which are attracting more companies to migrate to the cloud data warehouses. The first thing is increased demand data, right? So previously we used to have the POS transactions only to understand our business and to plan further. But nowadays data demand is increased. We are getting data from new sources. It can be social media, it can be from digital marketing vendors, it can also be Google Analytics, and this data is required for And this data is required for the data analyst to understand what's happening in the business, how to increase the customer experience, and at the same time sales. And this data helps the data which is coming from social media and Google Analytics. They help us to perform a lot of statistical analysis to predict the profit when they make changes in the business process. The data which comes from weblogs and Google Analytics, social media is huge. On-premise data warehouses cannot hold. To hold that, it is very costly game. Since data is there on the cloud, better we'll move our data warehouse to the cloud. Okay? Maintaining cloud data warehouse is not costly when we compare with on-premise data warehouse. And we have to pay to only those resources which we have used, and better integration to modern tools. Since we are in a big data era, most of the data is present on the cloud. The companies are showing interest to share the data over the cloud instead of using our traditional SFTP, FTP and shared folders kind of mechanisms. And we see a lot of ETL tools like Adverity, Medallion, Amazon Glue and NoSQL databases, and we see many reporting servers are migrating to the cloud. So cloud data warehouses has better connectivity, and definitely Snowflake has better connectivity compared to many of its competitors. And as we know, if we are using cloud infrastructure, we don't have much maintenance tasks, almost zero. As a customer of cloud data warehouse provider, we don't need to bother about their system upgrades. As a customer of cloud data warehouse, we don't need to bother about data security because almost all the cloud data warehouse providers, they are comply with the HIPAA and high trust CSF regulatory guidelines, and they are providing different types of editions which are suitable to different kinds of organization. Snowflake has a separate edition called business critical edition, which suits to the companies which deals with more sensitive data. Since we have wide variety of data in our data warehouse, our users queue is also increased. Nowadays, data scientists, third parties who belongs to digital marketing, which includes email marketing, Facebook marketing, TikTok and Google ads. So there are new type of third parties has increased. Now let's see limitless storage and limitless CPU and elasticity. These are the basic features when we are on cloud. So we are aware of storage. We can add more disk to your cloud instance, or you can say EC2 if you are using AWS. It is just like your laptop. You can add more disk on the fly, and you can add more CPU to your machine. And elasticity. You can add on the fly when the demand is increased. If you don't need much resource, automatically the newly added CPU will not be utilized. And next, look at high availability. Basically, cloud vendors provide best disastrous recovery methods by using data replication in other cloud regions and by taking automatic planned database snapshots. I think you got the overall idea about the advantages of using cloud infrastructure to implement data warehouse. Other required. Here are the top competitors to Snowflake: Teradata, Amazon Redshift, and Google BigQuery. Previously, Teradata used to offer on-premise data warehouse. Even today, they are doing the same, but they came up with new layer which helps to connect cloud services and at the same time with the on-premise Teradata warehouse. In fact, it is a unified hybrid model. Overall, Snowflake is winning because of its easy to use and support to wide variety of file formats, due to its performance and due to connectivity to wide variety of cloud services. The systems which follow shared nothing architectures, they are called MPP systems, massive parallel processing systems, because every operation on shared nothing architectures will be performed in parallel. Okay, with the knowledge we have on the MPP system architecture, let's try to understand the architecture of Snowflake. Snowflake follows the layered architecture. The first one is cloud service layer, the second one is query processing layer, or you can say compute layer, the third one is database storage layer. Whenever user fires a query, that query reaches to the cloud services layer. Here cloud services layer is comprised of multiple servers. They coordinate each other to authenticate, to provide the resource to execute our statement, and to parse that SQL statement, and to make the execution plan to perform that SQL statement. Once the execution plan is ready, that plan will be sent to query processing layer. In this picture, you are seeing three different servers. Snowflake offers several number of MPP systems. They called as extra small, small, medium, large, extra large virtual warehouses. They are defined based on the configuration they have. Suppose think that this is a small warehouse. Think that this is a medium virtual warehouse. Virtual warehouse is an alternate name to the MPP system in Snowflake. Think that this is a large virtual warehouse. Since it is like small, it has 2 nodes and each node has 8 threads. So here total 16 processors are there. 16 threads are there. Here, since it is a medium warehouse, it has 4 nodes. Since each warehouse has 8 threads, it contains 32 threads. Since it is a large warehouse, it has 8 nodes, so that it has 64 threads. Based on the type of query we are trying to execute, we can choose on which warehouse, on which virtual warehouse our query to run. If you know that the query you are submitting takes less resources, then you can choose small. If you know that the query you are firing, it needs to fetch huge amount of data from the disks and perform the complex operations, then in that case you can choose large warehouse to run your query. Okay? So underneath we have database storage layer. Here we have multiple disks. Whatever the data we are storing in the Snowflake, that data gets stored in these disks. Let's summarize. So whenever a user submits a query, that query will be submitted to cloud service layer. That query will be parsed. Execution plan will be created in the cloud services layer, and that execution plan will be sent to the virtual warehouse which you have chosen to use. Then virtual warehouse has number of threads. Those threads goes to the disks and brings the data whatever is needed to perform that particular query, perform the operations what it's supposed to perform. Once the result is ready, that result will be sent to the cloud services layer. Then cloud services layer dispatches the result set to the user who has submitted that query. And important point is that Snowflake uses the hardware of cloud vendors. Snowflake produces the database software to make these systems coordinate. Okay? So with the understanding on Snowflake architecture, let's get into the syllabus what we are covering in our training program. So the first one is introduction chapter, where we are covering the basics to understand Snowflake high-level architecture and Snowflake Editions. So for small size companies, they have one offering, and for the large enterprises, they have Enterprise Edition, and for those concerns which has more sensitive data, they have a different edition. And we will set up the work environment to practice. And then we'll talk about Snowflake handshaking tools to perform data engineering tasks. And we will discuss about database drivers which help us to connect to Snowflake through variety of editors and connecting to Snowflake through popular programming languages, so that we can embed our SQL statements in the programs. For example, firing a query from a Python program, or you can say executing a query on Snowflake from the Spark. Okay? And in this chapter we will be discussing about configuration file. Config file is used to personalize the session settings on the systems. In chapter number 2, we are purely focusing on low-level architecture of Snowflake. So we are trying to understand how the query is getting executed inside and how the data is getting stored inside the database. And we are going to take a close look on the operations of cloud service layer. And once we understand the concepts which we are covering in chapter number 2, you will get a great idea on how to optimize your queries. You will be able to do the diagnosis of the queries which are troubling you. And it helps you to effectively use the resources. That way you can save the bills, right? So in this chapter, we will understand how to assess the historical trends on your virtual warehouse. By the end of this chapter, we will understand how to assess the historical trends on your virtual warehouse. You will be able to understand the loads on virtual warehouse, and you will be able to plan better to meet your service level goals. And at the same time, you will be able to balance the Snowflake bills. Next, in chapter number 3, we will be spending time to understand the data dictionary of Snowflake. Data dictionary gives a lot of information about the objects that you have stored in the Snowflake, the information about your resource consumption, how much space you have utilized and how many credits are billed for it, and what is the load on each warehouse, and how many credits are consumed by each warehouse. All those details you will get by querying the Snowflake data dictionary. If you have thorough understanding on the data dictionary tables, think that you are the person who has the great understanding on Snowflake. And in the chapter number 4, we will be discussing about table functions. Table functions, it looks they are new in Snowflake, but actually they are not. So we have the stored procedures, right? So stored procedures may or may not return the values, and stored procedure can result in raw data type, right? So the same thing here. The table functions are similar to our stored procedures, which returns the raw type data. So in summary, table functions takes the values. According to the values that you have given, it returns the result from your tables. There are default table functions which Snowflake has given. So those helps a lot in our day-to-day activities when we are working on Snowflake. And in this chapter, we will be learning how to create a table function and how to use it. The default table function which Snowflake has provided, they help us to easily access the data which is in the data dictionary. They are very handy. And in the chapter number 5, we are spending the time on learning how to optimize our SQL statements by looking at the query profiler. To perform the query optimizations, we use the knowledge which we acquired in the chapter number 2. And here we are discussing the guidelines, how to write the queries in Snowflake and minimize cost of the query. And in the chapter number 6, we will be discussing various types of database objects, starting from creating a database, inside that creating the schemas, inside that creating the schema level objects. They are tables, views, synonyms, materialized views, working with the SQLs required to create these objects. And in the chapter number 7, we are discussing more about the data recovery features. So Snowflake has came with 2 core features which helps us to query the data which was in the past time. That is called time travel. And after a certain period of time, the data won't be available in Snowflake. That will be kept in fail-safe mode for a week period. So we will be discussing about fail-safe and the costs related to this time travel feature and fail-safe. And Snowflake also facilitates to replicate your Snowflake data on different cloud region. It helps us to have better disastrous recovery plan. And in the next chapter, we will be working with AWS CLI commands. So being a cloud data engineer, we should be thorough with CLI commands. So think that if your Snowflake is using Google Cloud Infrastructure, then you should know GCP CLI commands. Learning how to download the AWS CLI and configure it. You can access your files which are on AWS cloud from your local machine by using this AWS CLI. Snowflake consumes only the files which are on the cloud. Snowflake cannot directly pick the file from your local machine or from on-premise environment. Suppose if you want to load a file into Snowflake, you should place the file on S3 if you are using AWS cloud. If you are using Azure, you should place your file on blob storage. In the chapter number 9, we are going to discuss special database objects. They are stages, file formats, data shares, reader accounts, and there are advanced objects which are called streams and tasks. Okay. So data shares is the object which helps data sharing between one Snowflake account to another Snowflake account. If the other party don't have the Snowflake account, we can create a reader account for that particular party and we give the access. In this same chapter, we will be talking about credits consumed for reader accounts and the virtual warehouse the reader accounts use. In the chapter number 10, we are going to spend the time how to load the data in Snowflake. Generally, we use copy command. If you say copy and if you use the table name, meaning you are loading the data into the table. If you say copy and a folder name there, so you mean you want Snowflake to export the data into that particular folder from the Snowflake. And it is very simple because Snowflake helps us by giving compatibility to many file formats. And here we are learning how to debug the issues which occur during the data loading. And we are learning how to validate the file before starting the data loading. And how to optimize these data loading jobs. And what are the considerations, what are the guidelines that Snowflake is giving to prepare the smooth data loading jobs. And we will be discussing about the charges for data loading. Whatever the topic we pick up for the discussion, we always view through the architecture perspective so that a learner gets great idea on the Snowflake. Okay. So in the next chapter, that is chapter number 11, we will be discussing how to implement the data export jobs and how we have options for file format and copy. Similar way, data unloading jobs also have the file format and export options. So if you say you want the file to be exported in a JSON format, you can do it. Or you want to export type delimited CSV file with the double quotes, you can do it. You want the file which is compressed, you can get the zip file out. Here there are a lot of options, we are going to play with them. In chapter number 12, we are going to discuss about the Snowpipe. Snowpipe is offering to load the data continuously. So some applications demands to have the real-time or near real-time data in Snowflake warehouse. In those cases, we can use Snowpipe to continuously pull the data from cloud storage and load into the Snowflake. In this section, we will discuss the basics of Snowflake and what are the points we should consider before implementing Snowpipe and its limitations. We will discuss about ARN and storage integration. ARN is Amazon resource name. This helps us to connect to AWS services from any platform. In our case, it is Snowflake, and we will be discussing about a Snowflake database object called storage integration. This helps to define to which locations on the cloud the user should have permission to pull the files and which locations the user should not have. Using storage integration object, we can limit the access to the users on the cloud storage folders. If I use this storage integration, it covers my AWS credentials and folder which I go and connect to pull the files. So I don't need to explicitly specify my credentials there. And in this chapter, we are going to discuss about AWS notification services and the cost, because it's a Snowpipe, right? It's for continuous load. Whenever the file comes, so there should be a mechanism to tell Snowflake, hey, there are new files, we have to start loading. For these notifications, AWS charges. So we should know how much AWS charge for this service. And for the Snowpipe, since like it is a continuous load, once we configure, this runs, so Snowflake will take care of loading those files using separate MPP system, or you can say separate virtual warehouse. So Snowflake charges for this service. We will be discussing about how Snowflake charges for Snowpipe service. Next, in this chapter, we spend time in learning Snowflake Basic SQL and few useful functions and the commands we regularly use in our day-to-day work, which we must know to confidently work on Snowflake. And learning these will help to put up experience in Snowflake. So once you are thorough with these functions, you will see yourself as an experienced guy in. Next, we will be learning how to process the semi-structured data. So especially how to process JSON data. We will get the sample JSON file to load the data into Snowflake. Since JSON has hierarchies, and inside the hierarchies we may have dictionary items. So we will learn here how to flatten and load into Snowflake relational tables, and we will be discussing type of file formats that Snowflake supports. Next, in this chapter, we will be discussing about Snowflake functions, how in other RDBMS we are creating the functions. In the similar way we can create the functions in Snowflake. But in reality, since it is a OLAP machine, the usage of custom functions or UDFs is less. But Snowflake provides default functions which are helpful to do many tasks easily. And in this chapter, we are discussing about system parameters and variables. Basically, system parameters helps us to define defaults for your Snowflake account. What is the timeout period when I am trying to run a query? Or what is the concurrency level? I'm telling for example, but there are many more. And Snowflake provides facility to create the variables, store result of a query into it, and then we can use later in your SQL script. We will be learning that here. Next, in this chapter, that is user management and access control, Snowflake works with the roles. We cannot directly assign rights to the users. So rights should pass to users via roles. Previously, when we are an on-premise data warehouse, we used to give the access on the database objects. But here in Snowflake, we give the access to the users on the virtual warehouses as well. I can limit the users to use the warehouse up to large so that user cannot use the bigger warehouses. There are three default roles. They are account admin, sysadmin, and security admin. Among them, account admin is a super role, and this role has access to the Snowflake builds, whereas other roles don't have. And not only these, and we may need to create several roles based on the type of work they are doing. We will be learning here how to create the role and how to create the users, how to assign a role to the user, and how to grant the rights to use a warehouse, and how to grant the rights on the objects. Snowflake has a facility to clone the objects. We can clone a database, we can clone a schema, we can clone a table. So here we are learning what about the transfer of rights on the cloned objects. We will discuss this concept in this chapter. Then, and the important topic, that is understanding Snowflake credits. So here we are going to discuss. Generally, Snowflake won't talk in terms of dollars, it talks in terms of credits. And nowadays, like most of the service providers are using the term called credits, because if they use dollars, it is kind of a hard line. If you use credits, then it will give flexibility to change the value of credit. Suppose if you say one credit is $1, I'm taking an example, okay? Tomorrow they can redefine one credit is equal to $1.25. I think you got why most of the service providers are using credits instead of straight away specifying dollars for their services. Snowflake charges differently for different services. So how they measure the storage, how they measure the cloud service usage, how do they measure the compute? I mean, how do they measure the virtual warehouse usage? So these topics we are discussing here. So by end of this chapter, you will be able to understand how Snowflake is charging for the services. And we will take a sample bill and go through it. Next, we will be discussing about the framework. So far, we learned this is one side of the picture. The other side is how to automate the activities which you need to perform when you are working in data engineering department. It needs a framework, right, to automate your tasks. Here we will discuss about the framework design and how to maintain configuration tables, ETL log tables, and we will be learning what is the role of Unix and Python. This gives an idea how the things happen in real time. At the end, we will be discussing how Snowflake can be used for data lakes. So here we are going to understand what is data lake and what is the difference between data warehouse and the data lake, and what is the advantage having the data lake in Snowflake. We will spend a small amount of time to discuss day-to-day activities of data engineer. After finishing the above demonstrated syllabus, I am giving 3 hours of bonus session. In that 3 hours, we will be discussing something which related to the Snowflake and data engineering topics that helps the students to crack the interview easily and to stay ahead in the team. Thank you for attending this class and see you